Good afternoon. Today's lesson is going to be 4.1 in the textbook and 4.2, but we're supplementing this Common Core material, and it's going to touch on some topics that our textbook doesn't touch on a lot. This is not going to be hard. Hopefully this video will be short, but it's just going to lead you through this worksheet. So at the top, we're going to be talking about congruents and triangles. Remember that congruent means exactly the same size, shape, measure. And our essential question is, what can you conclude about two triangles that are congruent? When you know that two triangles are congruent, you can make conclusions about the sides and angles of the triangles. So this is not difficult at all. When you look at this first example, what I want you to focus in on is this notation. Triangle ABC is congruent to DEF. We've talked before, but I just want to emphasize that the order that the letters are listed is very important. What this tells you is that angle A is congruent to angle D because they're listed the same. So if you look over in this picture, angle A is going to be congruent to angle D, so that tells you that angle A has got to be 73 degrees. Two other angles that are congruent are the second 2 points that are listed, B and E. So looking at your picture, if E is 65, then B has to be 65. And obviously the last two that are congruent have to be C and F, so that's got to be 42. Not only do these letters in order tell you the angles that match up, but they also tell you the segment. So if you notice here, A to B are listed first, so the segment from A to B is also going to be congruent to the segment from D to E. So if you look back at your picture, AB is 2.6, then D to E will be 2.6. Another way to pick that out is, do you see that A to B is the segment that goes from the 65 degree angle to the 73 degree angle? Looking at this picture, this is the segment that goes between those same two angle measures. Then also you can say, looking back at this picture, the next 2 points make segment BC is congruent to EF. So BC is congruent to EF. And then as you can see, we've got one segment left. D to F is going to be congruent to A to C. And once again, you can tell that because notice that D to F is going between these two angle measures of 42 and 73. Same thing here. Okay, so if you guys can take a minute to, I think we've go ahead and read through this and answer these questions. When you get down to here, this gets a little bit tricky. If you know that triangle ABC is congruent to DEF, what 6 congruent statements about segments and angles can you write? So you're going to write 3 congruent segments that all have to do with angles. So for instance, angle A is congruent to angle D. That's 1. Angle B is congruent to angle E. And angle C is congruent to angle F. That's what they mean by a congruent statement. The other 3 statements are all going to have to do with segments. So segment AB is congruent to what segment? Segment BC is congruent to what? And so forth. So go ahead and fill that in. If you need to pause the video, go ahead and do that. Okay, moving on, at the bottom here it says, when two triangles are congruent, the corresponding parts are the sides and angles that are images of each other. So we're going to introduce this phrase, corresponding parts. You write a congruent statement for 2 figures by matching corresponding parts. So up here, A and D are 2 angles that are corresponding parts. Segment AB and segment DE are corresponding parts of the triangle. Okay? So if we go back to here, in other words, the statement triangle ABC is congruent to triangle DEF contains the information that AB corresponds to DE and so forth. I think we hit on that pretty well. Okay, if you turn the page, this is a theorem that you will be using in your proofs for a lot of the remainder of the year, and we're going to abbreviate it just like they do here. The following theorem is often abbreviated CPCTC. The proof of the theorem is similar to the argument presented in the previous example. Okay, so where do we get CPCTC? It's called corresponding parts of congruent triangles are congruent. Lots of words, but it's pretty obvious. If two triangles are congruent, then corresponding sides are congruent and corresponding angles are congruent. Okay, so in a proof, you can see how this would work. If this is your given, if you're given that two triangles are congruent, you can automatically come up with 6 different statements because we know corresponding parts of congruent triangles are congruent. So if you needed in your proof to show that angle A is congruent to angle D, your reasoning would be CPCTC. Corresponding parts of congruent triangles are congruent. Or if you needed to show that segment AB is congruent to segment DE, your reasoning would be CPCTC. Okay, so we're going to use that a lot, and you can make that abbreviation, but you need to be able to articulate that this means corresponding parts of congruent triangles are congruent. Okay, as we've talked before, the converse of statements is not always true, but in this case, the converse of CPCTC is also true. So that means if you flip it around, it is true the other way. That is, if you're given two triangles and you know that all 6 pairs of corresponding parts and corresponding angles are congruent, then you can go to the conclusion that the triangles are congruent. Okay? All right. Please work through example 2 using corresponding parts of congruent triangles. I think it's pretty self-explanatory. It's going to give you a little bit of practice matching these things up. Okay. All right, and then continue down to reflect 2A and 2B. And we'll talk about that first thing tomorrow. All right, so if you turn this over to the practice section, I'm just going to have you do a few. So if you can please do 1, 3, 5, and 8, and then I think you'll be done. All right, have a good evening. Hopefully you're not doing this at 10 o'clock at night.